Hello friends, welcome to UGPG Mathematics. In this video, I am going to solve problems from IIT JAM 2018. For more videos, please subscribe to our channel. Thank you. Let us see the question. So the question is, which of the following is true? And we have given four options. The first option is Zn is cyclic if and only if n is prime. By the way, this is from section A, so only one option is correct. So the first option says that Zn is cyclic if and only if n is prime. This is false because Zn is always cyclic for any n. So this is not true. The second is every proper subgroup of Zn is cyclic. This is a well-known result. We know that this is true. The third is, so here the answer is B, but we will go for C, whether C is correct or D is correct, because if this question is asked in section C or B, then we will have to choose the all correct options. So go for C. So every proper subgroup of S4 is cyclic, which is not true because you take A4, set of all even permutations of a group S4, then we know that this A4 is a subgroup of S4, and we know that A4 is not abelian. So this implies A4 is not cyclic subgroup. So A4 is not cyclic subgroup, and hence every proper subgroup of S4 is not cyclic because the A4 is a counterexample. Now the option D says that if every proper subgroup of a group is cyclic, then the group is cyclic, which is not correct because if you take the group of quarter ions, let us say Q is equal to 1 minus 1 I minus I, J minus J, K minus K. So all of you are familiar with this quarter ions group. So we know that the only subgroups are the 1 minus 1, then 1 minus 1 I minus I, then 1 minus 1 J minus J, 1 minus 1 K minus K, and Q. So these are all subgroups of the group of quarter ions, but we have asked about proper subgroup, correct? So we just have to focus on proper subgroup of the group Q. So this is not here. Now let us say whether these are cyclic or not. So just see that this identity, the subgroup identity is just generated by 1, correct? Now this is generated by minus 1 because minus 1 square is 1 and this minus 1 element is here. So, and this is generated by I or minus I. I am writing this as I. Similarly, this is generated by the element J, and this is generated by the element K. So these are all the subgroups of Q and which are cyclic. So these are cyclic proper subgroups of the group Q. But we know that this Q is not abelian, and hence it is not cyclic. So we have a group with every proper subgroup is cyclic, but the group itself is not cyclic. Or you can take the second counterexample as, let us say G is equal to Z2 cross Z2, which is same as 0 0 1 0 0 1 and 1 1. This group is not cyclic this is not cyclic, but it's every proper subgroup. That means these proper subgroups are just, we take Z2 cross singleton 0, or Z2 cross singleton 1, or Z0 cross singleton 0 cross Z2, and singleton 1 cross Z2. So these are the subgroups which are not, these are the proper subgroups which are cyclic, but Z2 itself is not cyclic group. Let us solve another question. The question is, we have given an is equal to bn plus 1 upon bn, where b1 is equal to 1, b2 is equal to 1, and bn plus 2 is defined by bn plus 2 is equal to bn plus 1 for n belongs to the natural numbers n. Then limit n tends to infinity of an is, we have given the 4 options. So let us find out the limit of this an. So an is nothing but bn plus 1 upon bn, where this bn is defined by, we have given the relation bn plus 2 is equal to bn plus bn plus 1, and where this b1 is equal to 1 is equal to b2. So let us just see what is this sequence. So b1 is nothing but 1, this is second is b2, third is you take the addition of b1 plus b2, that is 2, then fourth term is you take the addition of the second term and the third term, that is 1 plus 2, which is 3, then you take addition of first two terms, so it is 2 plus 3, which is 5, then take 3 plus 5, which is 8. So this is just a Fibonacci sequence, and we have to solve the limit of bn plus 1 divided by bn. So write this bn plus 1 as, by the definition you just replace this n plus 2 by n plus 1. That means you subtract 1 from this suffices. So this is just b n minus 1 plus b n, correct? So and divided by bn as it is. Now this is same as b n minus 1 divided by bn plus bn upon bn, which is same as b n minus 1 upon bn plus 1. bn gets cancelled. Therefore this an is equal to bn minus 1 upon bn plus 1. Now let us just put the value of this an. We know that an is nothing but bn plus 1 upon bn. So just put the values. So this is bn plus 1 upon bn, which is equal to 1 upon bn divided by bn minus 1. This is same as this, correct? So plus 1. This is just a small adjustment. Now see that this bn plus 2, we have given this bn plus 2 is same as bn plus bn plus 1, correct? And this is for all n belongs to the natural numbers. So just replace this n by n minus 1, because it is true for all n, so it must be true for n minus 1. So when you replace this n by n minus 1, we will get, this is n plus 1 is equal to bn minus 1 plus bn, correct? So this is also true for the given sequence bn. Now let us say that this sequence bn plus 1 upon bn converges. That means an converges, because we have to find out the limit, so it must converge. So let us say limit of an as n tends to infinity is L. That is limit of this bn plus 1 upon bn is equal to L, because an is nothing but this. But now see that this is just a quotient of this bn plus 1 upon bn, and this sequence converges, so this means it must be equal to this limit as n tends to infinity of bn upon bn minus 1, correct? Because this is the high bn, and you take just the next term of this and take the quotient, and this is also same as the limit of this bn minus 1, take the next term bn and take the quotient of this sequence, these two sequences, so limit must be same. And now you just put this L here, so to find out the value of L, just put the value this as L, so taking limit on both the sides, we will get this as L is equal to 1 upon L plus 1. Now just solve it for L, so we will get this as L square minus L minus 1 equal to 0. Now just solve this using this. Suppose we have ax square plus bx plus c equal to 0, then the roots are given by minus b plus minus root b square minus 4ac divided by 2a. So I am just solving this, so this is L is equal to L minus 1 plus minus square root of b square is 1 minus 4 into ac divided by 2 times a. So this is same as L is equal to 1 plus minus square root of minus 4 plus 4 is just square root 5 by 2. Now see that these all the terms of this sequence are positive, so the limit cannot be negative, right? So this is same as 1 minus root 5 by 2 or plus 1 plus root 5 by 2. So we know that this 1 is less than square root 5, so this is a negative quantity, so the sequence cannot converge to this 1 minus root 5 by 2, as it should converge to a positive quantity. So the limit of this sequence must be 1 plus root 5 by 2. So the answer is option D, which is 1 plus root 5 by 2. Now let us solve another question. The question is, if we have this set v1, v2, v3 is linearly independent set of vectors in a vector space over R, then which of the following is also linearly independent? So let us solve it. There are 4 options. Let us go option wise. So the first option says that this set is linearly independent. Let us see whether this is independent or not. So just you just take the 2 times the first vector, that is, I am saying that vector as A. The first vector is A, this is B, and the third vector is C. So 3 into A plus the vector B is equal to, this is 3v1 plus 3v2 minus 3v3 plus 2v1 plus v2 plus 3v3 is same as this 3v1 plus 2v1 is 5v1, then 3v2 plus v2 is 4v2, and then minus 3v3 plus 3v3 is just 0. So this is 5v1 plus 4 times v2. This is nothing but the third vector C. So I can express this vector, the third vector C, as a linear combination of 3a, the first 2 vectors. So this the option A, the set this is dependent. So this set is dependent. So this is not independent. Let us go for the second option B. So call this as A, B, C. So just take A plus B is same as V1 minus V2 plus B is V2 minus V3, which is same as just V1 minus V2 plus V2 is 0, and this is minus V3. Now I can write this as minus of, you take minus common, so V3 minus V1, and this is just nothing but the third vector V3 minus V1, so this is just as minus C. So again we have this C as minus of A plus B. That means this is just a linear combination of first two vectors. So this set is also dependent because one element is dependent on the other two elements of the set. So this is dependent. Now for C, you just take, now there are four vectors V1, let us say A, B, C and D. So I am just taking the addition of first three vectors, that is A plus B plus C. So this is equal to V1 plus V2 plus minus V3 plus V2 plus V3 minus V1, then plus V3 plus V1 minus V2, and this is same as V1, let's cancel, this is V1 plus this is V2 and then with V3, right? So this is nothing but the fourth vector, so this is equal to say D, and hence we can express this D as a linear combination of A, B, C. So this C is also the dependent vector and dependent set, and hence we have this all A, B, C are dependent. That means the fourth one must be linearly independent because only one option is correct, so it has to be correct. But we can see this by, we just take the determinant of all the coefficients and take it column wise. So in this the coefficient of V1 is 1, V2 is 1 and V3 is 0. So likewise I am calculating the determinant. So determinant of, in this case it is 1 1 0, take column vector. So and next is V2 plus 2 times V3, that means 0 V2 and 2 times V3. Now this last is 3V1, V2, the coefficient of V2 is 0 and it is V3, so 1, coefficient is 1, and just take the determinant of this. So this is equal to 1 into 1 minus 0 plus 3 times, this is 6 minus 0, so it is same as 1 plus, which is not 0. We just want a non-zero quantity to show that this is linearly independent. So D is the set given with D, given in D is independent, and hence this option D is the correct option. Now let us solve another question. We have given the family of asteroids x raised to 2 by 3 plus y raised to 2 by 3 is equal to a raised to 2 by 3, and the question is about the family of trajectories, orthogonal trajectories, correct? So we have to find out the equation for orthogonal trajectories of this family of curves. So the standard way is you just take the differentiation. So we just have to first find out the differential equation, and then in that you just replace this dy by dx by minus dx by dy. So let us solve it. So differentiating it with respect to x, we will get this as 2 by 3 into x raised to 2 by 3 minus 1 is minus 1 by 3 plus 2 by 3 into y raised to minus 1 by 3 into dy by dx is equal to, this is a is the constant, so its derivative with respect to x is 0. Now 2 by 3 will get cancelled from both the sides, and so this is just equal to x raised to minus 1 by 3, and you just replace here dy by dx by minus of dx by dy and take it to the left right hand side. So this is just equal to y raised to minus 1 by 3 into dx by dy. We are replacing this dy by dx by minus dx by dy. So just keep in mind dy by dx to minus dx by dy to find out the orthogonal trajectories. So just solve it. So this is just equal to, you take dy here and this, so this is just equal to dy, take this in the denominator, so minus 1 by 3 is same as dx upon x raised to minus 1 by 3. So this is just equal to y raised to 1 by 3 dy is equal to x raised to 1 by 3 dx. Now take the integration. So integrating on both sides, we will get this as y raised to 1 by 3 plus 1 by, this is just 1 by 3 plus 1 is equal to x raised to 1 by 3 plus 1 by 3 plus 1, and you just take the constant of integration. Let us say this as c raised to 4 by 3. So this is the solution of the differential equation when we replace dy by dx by minus of dx by dy. So just simplify it. We will get this as y raised to 4 by 3 is equal to x raised to 4 by 3 plus, we multiply throughout by, and this is as 4 by 3 into say c1 raised to 4 by 3. This constant of integration is just because I have taken just because the options contains like this, so these are the options, so I am taking this as c raised to 4 by 3, or you just call this as c1 so that the coefficients also will be adjusted after some time. So this is just equal to, now the options are in terms of the first variable is x and the second is y, so just write in this form. So this is equal to just x raised to 4 by 3 by 4 by 3 minus y raised to 4 by 3 divided by 4 by 3 is equal to c1 raised to 4 by 3, or just minus c1 raised to 4 by 3. And now you just multiply throughout by 4 by 3, so we will get x raised to 4 by 3 minus y raised to 4 by 3 is same as 4 by 3 into c1 raised to 4 by 3 minus. Now you call this whole quantity as just c raised to 4 by 3 because we can adjust this constant of integration. Now this is the option B. So this is the correct option. Let us solve another question. The question is, we have given a vector space of polynomial functions of degree less than or equal to 3, and we have given a operator, linear operator t from v to v defined by t of f of x is equal to f of x minus x times f dash of x, and we have to find out the rank of this transformation t. So just find out the matrix for this t. So we know that the basis for this vector space B is equal to 1x, x square and x cube, because the vector space is a polynomial function, consists of polynomial functions of degree less than or equal to 3. So just find out the matrix of t with respect to this basis, standard basis. So the matrix of t, we can write this as by this symbol, and it will be a 4 by 4 matrix because the basis contains 4 vectors. How to write this matrix? That means you just take the image of all these elements. So first you take 1, so this t of 1, and this fx is nothing but your basis element. So t of 1 will be, fx is 1, so it is 1 minus x into, you take the derivative of fx, that means derivative of 1, which is 0. So this is just equal to 1. Now take second vector, so it is x. So t of x will be just, you take the function fx, which is x minus x times, you take the derivative of x, so it is 1. So x minus x is 0. Now take the third element here, so it is x square. It is same as fx, you write this fx as just x square minus x into, take the derivative, so it is 2x, simplify it, it will be x square minus 2x square, which is just equal to minus of x square. Now just take the third element, which is x cube, which is same as, you take fx, which is x cube minus x into, take the derivative, so 3x square, and simplify it, x cube minus 3x cube, which is same as minus 2x cube. Now you write this one in the linear combination of these basis elements. So 1 is equal to, just I am writing here, so 1 is equal to 1 into 1 plus 0 into x plus 0 into x square plus 0 into x cube. Now these coefficients, while writing this matrix of t, you put in the vertical manner. So it is 1, 0, 0, 0. Correct. Now for second, the t of x is 0. So you write this 0 as, this t of x is 0. So write this 0 in the linear combination of the basis elements. So 0 can be written as 0 into 1 plus 0 into x plus 0 into x square plus 0 into x cube. Now write these coefficients in the vertical arrow. So it is just 0, 0, 0 and 0. So the third will be t of x square is just minus x square. So write minus x square as a linear combination of basis element, which is equal to 0 into 1 plus 0 into x plus minus 1 into x square plus 0 into x cube. So this is the coefficients are 0, 0, minus 1 and 0. Now last is t of x cube, which is minus 2x cube. You can write this as 0 into 1 plus 0 into x plus 0 into x square plus minus 2 into x cube. So the coefficients are 0, 0, 0 and minus 2. So right here minus 2. Now see here, this matrix is just a diagonal matrix, and the second row is 0. So the number of linearly independent rows are 3, and hence its rank is 3. So this is the correct option. Now let us solve another question. The question is, we have to find out the tangent plane to the surface z is equal to x square square root x square plus 3y square at the point 1, 1, 2. So these are the 4 options. Let us find out the tangent plane. So write this z is equal to f of xy, which is equal to square root of x square plus 3y square. And now you just use the tangent line approximation to find out the tangent plane to the surface. So it is given by, the tangent plane is given by z is equal to f of x naught y naught plus fx evaluated at x naught y naught into x minus x naught plus fy, which is evaluated at x naught y naught and into y minus y naught. So this is the tangent plane approximation, where this x naught y naught is the point given to us. So it is x naught y naught z naught is equal to 1, 1, 2, which is given to us, and this z naught is just equal to f of x naught y naught. So just put the values. So we will get z is equal to f of 1, 1, x naught y naught is 1, so plus fx at 1, 1 into x minus 1 plus fy at 1, 1 into y minus 1. So just find out the partial derivatives and put the values. So f of 1, 1 is, just put this value 1 plus 3 times 1, which is square root 4, which is same as 2, and plus you just find out fx. So fx is equal to, we know that f is just square root x square plus 3y square. So it is same as 2x divided by 2 times square root of x square plus 3y square. So it is same as x upon square root of x square plus 3y square, and you just put the value of x is equal to 1, y equal to 1. So fx evaluated at 1, 1 is same as 1 upon square root of 4, which is same as 1 by 2. Similarly, you find out fy at 1, 1. So fy will be just equal to, it is same as 6y upon 2 times square root of x square plus 3y square. So this is just equal to 3y square root x square plus 3y square. Now find out fy at point 1, 1. So fy at 1, 1 is just equal to 3 upon square root of 4, which is 3 by 2. So just put the values in this equation. So we will get z is equal to 2 plus This fx at 1 1 is 1 by 2 into x minus 1 plus fy at 1 1 is 3 by 2 into y minus 1. Now let us simplify it. So we will get this z is equal to 2 multiply by 2 throughout the equation. So we will get 2z is equal to 4 plus x minus 1 plus 3y minus 3. So just simplify it. We will get this as x plus 3y minus 2z is equal to 0. So option is this B option is correct option. So this is the answer, but I have a shortcut method for this. So for this you just take the gradient of f here. So just denote it by gradient of f evaluated at 1 1 2 and take the dot product with this vector x y z equal to 0 because we have to find out the tangent plane. So take its dot product with x y z vector is 0. So but I am using this f notation here, so let us just replace it by g, so there will be no confusion. So what is this g? G is nothing but we have given this surface z is equal to x square plus 3y square. So you just take it as square root x square plus 3y square minus z is equal to 0. You can write this as this. So you just take this surface as, you set this as g of x y z. So our g is the function of x y z, which is just equal to x square plus 3y square minus z. And now find out the gradient of g. So we know that how to find out the gradient. So this is just equal to gx, the partial derivatives, and gz. So we have already calculated the partial derivatives of this function, and it does not contain any term z. So the derivative of this with respect to x is just x upon x square plus 3y square, and we have evaluated at 1 1. So it does not contain z, so there is no question about the third point, so it is just 1 1. So 1 by 2. Then again same thing for gy, it is just 3 by 2, and just calculate gz at 1 1 2. So it is just 1 by 2, 3 by 2, and now see here g is equal to this. So the derivative of g with respect to z is gz, which is equal to, this is xy, so just take the derivative of minus z, which is just minus 1. And if you evaluate this minus 1 at 1 1 2, it will be just minus 1. So we have this gradient of g evaluated at point 1 1 2 is equal to this vector. So just we take the dot product with x y z, we will get this as 1 by 2, 3 by 2, and minus 1. Take the dot product with x y z, which is same as 0. So this is, from this we will get this as x, just solve it. So x by 2 plus 3y by 2 minus z is equal to 0, and now multiply throughout by 2, so it will be x plus 3y minus 2z is equal to 0, as we have seen. Let us solve another question. The question is, we have given Sn is equal to 1 plus 1 by 1 factorial plus so on up to 1 by n factorial for n belongs to n, and which of the following is true. So for the sequence Sn, so first option is Sn is convergent, converges in Q. Then second is Sn is Cauchy sequence but does not converge in Q. Third is the subsequence Sk raised to n is convergent in R only when this k is even natural number. And fourth is Sn is not a Cauchy sequence. So let us see which of this is true. So the sequence, our Sn is given by 1 plus 1 by 1 factorial plus 1 by 2 factorial so on up to 1 by n factorial. Now you just recall that this e raised to x is equal to summation x raised to n by n factorial. N runs from 0 to infinity. So when you put x is equal to 1, so we will get e is equal to e raised to 1 is e. So series n runs from 0 to infinity of 1 by n factorial. So this is just e is equal to, write this explicitly. So this is 1 by 1 factor, 0 factorial is 1 plus 1 by 1 factorial plus 1 by 2 factorial plus so on plus 1 by n factorial plus 1 by n plus 1 factorial plus so on. Now just note that this up to n factorial is just our Sn, correct? Because Sn is equal to the sum start from 1 by 1 factor 1 plus 1 by 1 factorial to 1 by n factorial. So you just write this series as, you can just take the limit as n tends to infinity of, take the sum of 1 by say k factorial, k runs from 0 to n. So you will get this series, the limit of this series as e, correct? So you can write this as just e is equal to limit as n tends to infinity of summation 1 by k factorial, k runs from 0 to n. Now this is nothing but our Sn, correct? So the series of this e has this partial sum Sn. The first sum of first n terms is denoted by Sn, which is the partial sum of the series. And when you take the limit, we will get the limit of this sum. That means the limit of this sequence Sn. So the limit of Sn is equal to e. Now see that this e is not in Q, correct? But this e belongs to R minus Q, irrational number. So it is a real number. So the series, the sequence, so this limit Sn is equal to e, which belongs to R. So this limit exists and it is not in Q. So the first option is false because it is saying that Sn converges in Q, but E is not in Q, so this is false. Now we know that if a sequence converges, then it is Cauchy sequence, because we know that convergent if and only if it is Cauchy when we take the space as R, the real vector space. So this sequence Sn is convergent and hence it is Cauchy sequence in R. And now note that this Q is a subset of R, so this is also the sequence is Cauchy in Q. So the second option says that Sn is Cauchy sequence but it does not converge in Q. As we have said that this is Cauchy sequence and also it does not converge in Q, so this is correct. Now we know that every subsequence of a convergent sequence is also convergent. So we have given this sk raised to n is a subsequence, so it is definitely convergent, but it is saying that only for even k it is convergent. So this is false because every k it is convergent. So the option D is, so C is false. Now option D is Sn is not Cauchy sequence. It is clearly false because we have just seen that it is Cauchy sequence. So the correct option is option B. Thank you.